All right, so we're going to start looking at slope here. So the slope of a line, it's the number of units the line rises or falls for each unit it moves left or right. So we're going to use this when finding our slope. Okay, we've got a couple types of slope. So you've got your positive. Note that as you go from left to right, this one is increasing. A negative as you go left to right is going to be going down or decreasing. If there's no slope, it's horizontal, it's flat. And then if it's straight up and down, that would be undefined. And the reason we'll see later, but essentially you're trying to divide something, a number by 0, and when you do that, you can't. And so it goes in as undefined. Okay, so just quick look at labeling these, which ones are positive, negative, undefined, or 0. So first one, it is going down as we go left to right, so this is negative. Oh, my pencil doesn't want to work. Okay, this one is increasing as it goes left to right, so that one's positive. Once again, it's going down left to right, so you've got a negative. This one is increasing as it goes left to right, so that's positive. Next one, it is going down, so it's negative. And then the last one, it's a vertical line straight up and down, so this one is undefined. So that's just going to help us determine our slope and what, if it should be positive or negative. Okay, so now slope is your rise over run, or your vertical change over your horizontal change. So now when we have 2 points, we can count that, especially when it's on a nice graph. We can count the units it goes up and the units it goes over. So it says to get from A to B, you move blank units up and blank units to the right. So we're going to make just a triangle here. And I'm just going to use this little one. So you go up 1, 2, 3, or up 2, and then you go over 3. So then we just plug those in for our slope, and it is rise of 2, run of 3. So our slope would be 2/3. Okay, they say the same thing for B to C. You're going to go 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6. So up 4 over 6. And what you'll see is this makes a equivalent ratio to 2/3. It's just doubled the distance. So when you simplify the slope, it's still going to give us 2/3. All right, next one. So to get from L to M, so we go up 1, 2, 3, 4, 5, 6, and over 2. All right, so we went up 6 over 2. So our slope is 6 over 2, which ends up being just 3. And that's what we'll see in this next one. From J to K, you go up 3 and over 1. So 3 over 1. And 3 divided by 1 equals 3 as well. Oops, not 1. It equals 3. Okay. So these are the same. It doesn't matter how far apart the dots are. There, as long as it's on a straight line, the slope is always going to be an equivalent ratio to itself. It's always increasing at the same amount. So just that, what relationship do you see between the two slopes? They both equal the same amount when you simplify. All right. So now we're just going to look. Let's see, you go down 3 over 1, 2, 3, 4, 5, 6. So when you go down, that'd be considered negative. So down 3 over 5. So this would be negative 3, positive 5. So then what we end up with, our slope is a negative 3/5. Okay, here we're going to go down. So there's 2, 4, 6, 1, 2, 3. So we go down 6, that's a negative 6, and we go in 3. So our slope is negative 6 over 3, which equals a negative 2. All right, this one we don't have points per se. And so this one we're just going to kind of look and guess at about where it actually hits a solid number. And so there might be a little bit different answers here, but I'm going to say that's a point right there. And I'm going to use that point right there, and that's going to be right in the middle, so I'm going to say this one is negative 2.5. Oops. And then it's right on the x-axis, so it would be 0. Okay, so rise here is going to be 1, 2. Then we've got a half, and then 1, 2, 3, 4, 5, 6. So then we are going to go up 2 over 6 and a half. Okay, just make sure, yep. All right, so now our slope is going to be 2 over 6.5. When we're dealing with a fraction, we want whole numbers. So if we double 9.5, we're going to get 13. So we're going to rewrite this as 4/13. So our slope is 4/13. For every 4 you go up, you move to the right 13. All right. So another way to look at this is when you have your points, you're looking at the change vertically, which is going to be in your y here, divided by the change in your x, or that's your run. So without plotting, we can solve this. We just put m is equal to, so this is our second term, this is our first. So we just follow the equation up here, y2, which is 4, minus 2 divided by, now it's our first x, or sorry, our second x, x2, which is 3, minus a negative 2. So this is our y1, y1, this one was our y2. This is our x2, this is our x1. So all I did was plug those into this equation here, down here. So now we can actually solve. So 4 minus 2 is going to be going to give us 2, and then 3 minus a negative 2 is going to give us a 5. Remember, when you're minusing a negative, it's the same as adding. So instead of 3 minus a negative 2, you could rewrite that as 3 plus 2. And so we have our slope of 2/5. And if we plot our points here, you would also see that if you set up and did the rise over run, we go up 1, 2, 3. And then we go over 1, 2, 3, 4, 5. So I'm getting 3 over 5. So there's something off there. I graph my first point at -2, 2. That checks out. And then this one is, oh, yes, because I went to 3, 5. My second point I plotted wrong. Should have been there, which is 2 up and over 5. So that all checks out, 2/5. Okay, in this one, right, if these are the two lines it passes through, it's increasing as it's going up. So this one would be positive. And what you'll see when you put in your values, negatives will come out if it's a negative slope, positives if it's a positive slope. Okay, so same thing. We take our y2 minus our y1. So we've got m is equal to 2 minus 2. And that's going to be over x2, which is 3, minus a -1. Okay, so we've got 2 minus 2, which equals 0. And once again, we've got 3 minus a -1, so we actually add those together, and you get 4. Right? So 0 divided by 4 just equals 0. So this is a flat line, so meaning it is horizontal. And once again, we can plot those 2 points. Oops, I wrote that backwards. Okay, so at 2 we're at -1, and at 3 we're at 2. Nope, I didn't do that right. Once again, I did not graph those points correctly. All right, the first one is -1, so I go left -1 and up 2. Second one, I go out 3 to the right and then up to 2. And when you connect those lines, they are just a horizontal line along the y-axis at 2. So this one's slope would be 0. All right, you can go ahead and pause the video here. See if you can find the slope on these ones and then graph, and then start the video again, and then you can check your answers with mine. All right, so we've got our y2, x2, y1, x1. So this is just going to give us 3 minus 0 divided by, sorry, -3 minus 0, 3 minus 0. So that's going to leave us with -1 for our slope. So this one is going to be decreasing. Okay, we know that the origin right here is where our 0, 0 is. And then go to the right 3, down 3. And you'll notice that it is, in fact, going down as you go left, right. And so therefore it's negative. Right, next one. Once again, it's our y2 minus y1. So 1 minus 4. That's going to be divided by our x2 minus x1. That's 2 minus 2. We're going to get 0 here and negative 3 on top. You got a 0 as a denominator. You can't have that, so this one's just undefined. So we should expect to see a vertical line. So our first point at 1, we go up 2. Nope, see, I did it again. I try to graph it backwards. So go over 2, up 1. And then go over 2 and up 4. And you'll notice those just form a straight line. All right, so this is finding slope of a line both by looking at the graph, the drawing, or by given coordinates.